Okay, let's start drawing some orbital diagrams. And we're going to do the ground state. And you guys have always done ground state when you've done Bohr models. That's why you put the electrons in the first ring out from the nucleus first, and you filled that one, and then you went to the second, and so on. You were drawing the ground state without them being excited up to higher levels where they're not stable. Okay, let's start with hydrogen. It's simple. It has one electron. How do I know? I look on the periodic table, and that number above it, that's the atomic number, and that equals the number of protons, and for a neutral atom that equals the number of electrons also. So hydrogen just has one electron. Of course, it'll be in our lowest possible energy level, and we would write that just like this. Okay, boron, we look on the periodic table, and it's atomic number 5, so 5 electrons. I'm going to start at the first energy level, and the s orbital can hold 2. And then I'll go to the second energy level. The s orbital can hold 2. And then I'm going to the 2p, which is slightly higher energy, and I only have one left. Okay, so when I draw these, I will say, I'll do one up and one down. Each orbital can hold 2, and they have to have opposite spins. One up, one down. And then when I get to the 2p, I only have one electron. And it doesn't matter really where you show it, but we tend to just do like up, 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 down, down, down. And that brings me to another rule. You don't pair them up unless you have to. So when we start getting more, we're going to put one in each orbital, and then we'll go back and double up if we have to. And that actually is this next rule, that Hund's rule, that you don't pair up the electrons unless you have to. If they can each have their own orbital, that's better. So carbon has 6. So I'll go up, down, that's 4, and then 5, 6. So I don't put those two in the same orbital. Oxygen has 8. So 1, 2, 3, 4, 5, 6, 7. Oh, I'm going to have to pair up 1. Again, the typical way to write it is that up, 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 down, down, down. Okay, so we've got a pattern going, but it gets more complicated once you get up into the third energy level. So we do, since it's ground state, we do start at the bottom and we fill up orbitals that have the lowest energy. And the problem is that once you get to the third energy level, the pattern isn't as simple as you would expect. If I drew the fourth energy level in here, that's where the 4s is. And so since I'm filling from bottom to top, once I put electrons in the 3p, I do the 4s next. And then I do the 3d. And if I put the 4p, it goes right here. And so on. After that, they all get really mixed up. The 4d is up here. So I start filling the 5 before the 4 is full. Anyway, so this pattern up here, it does have a regular pattern, and I'll show you, but it makes it a little bit more complicated because we do go from the bottom to the top. So right here, the ground state is not always not in the lowest principal energy level. Okay, so the off-ball principle is when you use this pattern to determine the ground state of electron configurations. And this pattern, it is right most of the time, and when I have you do an electron configuration, we will assume that an atom obeys the off-ball principle. But anyway, so the pattern, it is kind of complicated, but this is a diagram to keep track of it. You can see that there's a regular pattern to how these are arranged. And then what the deal is with the arrows is the arrows are telling the order that they fill. In other words, they fill the 1s, and then electrons go in the 2s, and then electrons go in the 2p, and then the 3s, and then the next electrons will go in the 3p, and the next in the 4s, and then the 3d, 4p, 5s. So it gives you that order, and you can see that starting there, that's where they start skipping around and getting mixed up. So let's just put something here. After the 3p, they go to the 4s. And after the 4s, they go to the 3d. And then 4p, and so on. Okay, let's look at an example. Okay, to do an orbital diagram for potassium, we look on the periodic table and we see that potassium is atomic number 19. So it has 19 electrons. And so we draw these in order. So we need to know the order, and we could use that off-ball diagram to see. Every time I have an S, it's just 1. And then I'm going to do, so this is where if you're following the off-ball diagram, after the 3p, you have the 4s. Okay, and then let's see if we have enough yet. So I'm doing 19. I'm doing 2 per orbital. 1, 2, 3, 4, 5, 6, 7. There we go. That's 19.